We believe in a future where targeted antibiotic use is possible to save lives and preserve our ability to tackle bacterial infections for future generations.
If a patient is feeling ill, they would come into a clinic and that sample would be taken so we can work out whether there's bacteria in the sample or not and what species they are. Once we know the species, we can then decide on which antibiotics to apply to those bacteria, watch them grow, and that will tell the clinician which antibiotics to prescribe.
Doing that both helps the patient to get better faster, but also minimises the risk of sort of any side effects. Also, over the longer term at the population level, we think that optimising prescribing and using the right drug for each situation would limit or slow the emergence of antibiotic resistance.
Antimicrobial resistance is already causing up to 1.2 million deaths annually, and if there are no interventions, then this problem can just escalate. It may get to the point when a simple infection cannot be treated and patients may die from a simple cut on their leg or a simple lung infection.
The Oxford Martin programme on antimicrobial resistance testing is helping us develop a platform and a tool that will allow us to diagnose infections in patients within an hour and also inform a GP or clinician as to which antibiotics are correct in that situation.
The test kind of has these three parts. So one is taking the sample, processing it to get rid of the sort of gunky components which might cause problems with the imaging of the microscope. The bacteria that get harvested from the sample then get looked at under the microscope, and we can look at how the cells change in the presence of different antibiotics. And then there's a sort of a computer algorithm which processes all the images taken of sort of thousands of bacterial cells and helps us understand whether or not we can go ahead with treatment.
We'd envisage that it's available in GP surgeries, even pharmacies, of course in a hospital and in the A&E department, but it's portable enough that we could roll it out to field tents if there's an emergency like a natural disaster.
We're training machine learning models to pick out bacteria in images and then tell us whether or not they have changed in response to antibiotic treatment.
All humans are very good at this, at spotting differences in pictures. So what we've done is we've set up a platform that allows anyone from the public to log in and potentially classify sensitive or resistant strains based on a few feature changes that they may undergo over time.
It's available on the Zooniverse platform. And what this project is asking you to do is look at a selection of images we've taken with our microscope. So these are the same images that the machine learning model will be looking at. And we want you to determine whether the cells you're looking at are resistant or sensitive to different antibiotics.
The Zooniverse project is a great way to learn about antimicrobial resistance and what it means in real terms. And any time you spend on the platform will ultimately enable us to train better machine learning models to help us fight antimicrobial resistance.
To get involved, just log on to the Zooniverse website and look for infection inspection, and you can get started after a quick tutorial that just explains what you need to do and what task you have.
The Zooniverse project can be accessed on the Zooniverse pages, and that's called Infection Inspection.
You can also follow us on our Twitter account, and that's @InfectInspect.